Welcome to this brief introduction to PCB insertion loss measurement with Atlas for VNA. In order to extend our testing capability above 20 GHz, Polar's partnered with Anritsu to extend testing for insertion loss up to 43.5 GHz. We do this by connecting with an Anritsu 43 gig VNA. The method being used for testing insertion loss is the Delta-L method. It can be used in production or material qualification, and I'll show you a few screenshots of the Delta-L test and how to set it up, and then follow up by showing that it's always important that you cross-check by microsectioning and feeding your results back into a field solver when you're initially setting up insertion loss testing. Here's the familiar Atlas test environment with the list of test vehicles on the test coupon on the left hand side, the insertion loss curve on the right hand side of the screen, and the data log area at the bottom of the screen. The data has been processed from the S parameters from the VNA using eigenvalue Delta-L method, and a line fit has been made to the insertion loss curve, and you can see we've got a good line fit here extending right up to 40 GHz. Here's another example. Again, this is a different trace on the same test coupon, and you can see again the line fitted right from low frequency all the way up to 40 GHz, and there's a cutoff frequency which I'll show you in more detail a little bit later, showing you the maximum frequency where we're confident of credible results. If you look at the lower frequency, you can see the slight curve as the skin effect fully develops in the copper part of the trace. The Delta-L processing with eigenvalue processing allows the maths within Atlas to calculate the certainty of whether a particular point should lie on the line fit or not. And in this particular display, I've brought up three graphs: the processed line fit and the data processed by eigenvalues, and then the uncertainty for each point. So this shows that at the lower frequency there's a high uncertainty, and then as you get into a gigahertz or so, the certainty of the data points is very good, and then at this point at 30 GHz there's a very high level of uncertainty, and these two numbers are used to process the maximum frequency at which we can trust the results. So you get a cutoff frequency, and I'll show you that on the next slide. So I've just highlighted and popped out the results in the right hand side of the screen, and you can see here that there's a cutoff frequency. Again, this has been calculated automatically, and it says the maximum frequency that this result is credible at is 31.4 GHz. But we've got a good solid result and a good solid line fit up to that point. This is another test which shows you again the processed and fitted data, the uncertainty, and the raw S21 data that we're processing to calculate the final results. The Delta-L method takes in all four S parameters for the line. The test setup for making an insertion loss test with Atlas is very straightforward. You simply enter a description for the test you're making, the layer number if that's of use to you. For materials qualification or for critical tests, you can use 3-line Delta-L, but normally in production you'd uncheck that and use 2-line Delta-L. You specify the length of the short line for testing and the long line, the units in inches or millimeters, and the display loss per inch, and then the test limits, frequency cutoff, and the test limit for the frequency and the max dB loss at each individual frequency you need to sample in your test program. So it's very straightforward. It should be very familiar if you're an existing Atlas user. And here's another example test that I've displayed for you. Once you've got your test results, it's quite a good idea if you're working on a new project or a critical project that you microsection the board, the test vehicle, and take a microsection and measure it and pass the results into Field Solver. So here's a microsection. You can take the data off that microsection, including any surface roughness data you can get from the microsection, and you take that information and then feed that into a field solver such as SR9000, and there you can work out what you would predict the results to be based on the section data, the roughness data, and you can analyze from this data the biggest contributor to loss, whether it's copper loss, roughness losses, or dielectric losses. The field solver lets you do this analysis in great detail. Thanks for watching this brief introduction to Atlas for Anritsu VNA and the use of Delta-L for insertion loss testing on higher frequency PCBs. If you'd like further information, please do contact your local polar office, and you can find the details for contact on this slide.